All right, so now let's find some exact values. So we know I'm gonna make the kind of the unit circle looking thing. So when I think about the unit circle, I usually just kind of make a plus sign. And so what I want right here, this says the arcsine of 1/2. So that's really saying where is the sine of theta equal to -1/2. I find that it's helpful to say that out loud. You probably aren't going to write it, but arcsine is -1/2. That's saying where is sine theta -1/2. So think about when your sine is 1/2 at all, like what's our reference angle? So sine being 1/2, that would be at a pi over 6, right? The pi over 6 has the sines because sine is the y value. So that's going to be some kind of pi over 6. And remember that I'm only like working in these two quadrants. So I'm going from negative pi over 2 to positive pi over 2. Yes? So where is the sine -1/2? Well, that's right here. So my reference angle is a pi over 6, so I have to figure out which one. Well, do you remember that in this context, I'm going from negative pi over 2 to positive pi over 2. So I'm going to call that negative pi over 6. Now you might be saying to yourself, I thought it was 11 pi over 6. And the answer is, it is, in the proper context. So to put things in context, so if you were here in the classroom, I'm in my classroom right now, you would call me probably Mrs. Beaver, something like that. You would call me by my more formal name. Now, a whole bunch of you are literally friends with my children, and you have been to my house for dinner because I have known you since you were in kindergarten. So if you were at my dinner table, you would not probably call me Mrs. Beaver. You might even call me Julie because that's my first name. And so for family friends, you might call me by my first name. The difference is the context. In my classroom, you would not call me that. You would call me Beaver, not Julie. So here, the context, the formal name that we're going to call this pi over 6 is negative pi over 6, as opposed to 11 pi over 6. Are they the same thing? Yes. Context matters in how we name things. All right, next one. Sine inverse, which is the same thing as arcsine. Sine inverse is square root 2 over 2. This should make you excited. I told you these would be your favorite. Okay, so that says where is sine theta equal to square root of 2 over 2? Well, you're like, hey, pi over 4s. You are right. And then I think, okay, so is it this pi over 4 or this one? Well, it's positive, so therefore it's this one. Ooh, what just happened there? So that is positive pi over 4. It's like a puzzle. Okay, what do we got? Arcsine, negative root 3 over 2. Okay, so where is the sine? Like, what's your reference angle? Is that a pi over 6, a pi over 4, a pi over 3? Is it pi over 3? Because you want it taller, but is it that pi over 3 up there, or is it this one? It's this one because it's negative. So that is at negative pi over 3. Again, could you call it 5 pi over 3? Yes, but in this context, it's important to go negative pi over 3. Okay, last one. Sine inverse of 2. When is the sine 2? Well, what's the highest sine you can have? 1. So can you have 2? You cannot. Remember we talked about the range being -1, +1, and or like the domain of what you put in, the highest it can be is 1. So no solution. It's too big. Which if you plugged that into your calculator, you would find that. If I looked back at my graph, do I have the graph? Hold on. Ha! There's the graph. Highest it goes is 1. So 2 doesn't work. There you have it. That's how we work backwards. In the next video, we'll talk cosine inverse, arc cosine, and arctangent.